Okay, so in this particular video, I'm going to show you the model matrix on the first set of fine tuning that we have done on the intelligent data set that we have just made in the previous video. In this particular data set, as you can see that this is the fine tuning of the model which is trained on the intelligent data set, and this is the matrix that in front of you is the matrix of the test data set. I don't know if it is clearly visible. This is 0.925 as the average MAP 50 to 95 of all the classes. Now this is very important to be noted that we are working on a semi-supervised pathway. We have not applied any semi-supervised section. We have just taken 10% of the images. We have trained, fine-tuned the YOLO with just that 10% of the images, and we are testing it on the remaining 90% of the images. Now that is a very interesting result that we are getting. And what is that? The MAP is reaching 0.925. But if you are surprised, don't be surprised yet, because this was ran in the ISI campus with 150 epochs and a batch size of 2 over 9 hours of duration. So this is that data set. But let me show you another version of the same that would run on Kaggle out here. This is the model fine-tune intelligent. Now this is just the same code, right? And I'm not going to just show you all that, but we can just have a clear-cut understanding from this, and just showing you a bit of code so that yeah, if you can clearly see, sir, uh, we are having in this particular we have made the YAML file. After creating the YAML file, we have just fine-tuned the model, right, for 30 epochs. As you can see, the fine-tuning is done for a total of 30 epochs, and essentially this is for the random data. Sorry for my confusion. This is for the random data. For the intelligent we have it, but it is not here. For Kaggle, I think it's not even required as well, right? So as you can see, the MAP values, these are for the random data. Okay, my bad. Let me just show you the MAP values. Yeah, so these are for the random values, and these are for all the 24,820, and you can see that the MAP is reached 0.959, almost 0.6 if we take it overall, and for the motorcycle it is 0.835. So this is how the MAP is ranging. And if you are surprised, don't be surprised yet, because the entire thing was done, the entire model was evaluated only for 30 epochs with a batch size of 16, so this is the training matrix on which we have trained it. A similar result, I am unable to show you the result out here, but a similar result was arrived when we fine-tuned the model on the intelligent one a bit less than the random one. A, a very slightly lesser result from the random one we received in the intelligent section. We have also fine-tuned the random model over 150 epochs at ISI machine with a batch size of 2, so that we can keep the results steady in both the directions, and out there also the model has performed greatly. I'll just show you the matrix of the particular field just right now. Here is that. This is the ISI machine on which we ran it for 150 epochs. I can just show you the uh, code where we have ran the system for 150 epochs out here. 150 epochs with a batch size of 2, uh, and yeah, there is all that stuff. Let me just head over quickly to the test data set. Out here you can see the matrix, right? It is all the images have got a 0.98 mAP for the random data set, and that's where we means you can say that land was snatched from our feet because we were thinking that intelligent is intelligent. But out here we came to know that intelligent data set is actually performing worse than the random data set. Now the point is intelligent is not performing bad. It is giving us 0.92. It is giving on the local machine at ISI. It is giving us 0.96 as MAP at the Kaggle window. So it's not performing bad. But in both the situations, the random data set has slightly outperformed the intelligent data set. So that was a point of concern. And this was when we also explored the Drashti data set and came to know that this data set is having huge similarity. I've already told you in the previous section, but there is a repetition of the same word that this dataset is extremely similar. The images are very highly similar, and therefore the mAP is coming to be very, very high. And remember this that we are yet just feeding the model with 10% of the data, while the authors, when done a completely supervised learning, got an mAP of 0.96 on the YOLO V11S model. We are not yet using SOTA architecture like YOLO V11X or something like that. We are just using the second to base model, YOLO V11S, and we are getting such great values of mAP. Now, this is when we just got uh, means we just got confused that what to do henceforth. Let me show what other works we did. Okay, so this was it, and I have shown you majority of the things before before we enter into the SSL pipeline. But yeah, that's our observations that we have received. There are other things as well, but they were just experimental, and we have shown you the major amount of things.